So you should be familiar with the binomial expansion, which says that if you take 1 plus x to the power n, then that's the sum from k is 0 up to n of the binomial coefficient n choose k multiplied by x to the k. So the purpose of this demonstration is just to explain why exactly that works. Okay, so here we're looking at 1 plus x to the power 7. Right, so we can write out 7 factors of 1 plus x. And we can imagine expanding this out, right? And so when we expand it out, we have to take, from each of these 7 sets of brackets, we have to either take the 1 or we take the x. Okay. So here we've kind of illustrated this where we're taking the x from factor 2 and the x from factor 3 and the x from factor 5 and 1s from factors 1, 4, 6 and 7. Okay, so when we do that, we've got these 3 x's here, so that gives us a term x cubed. Okay, and we do the same if we took x's from factors 2, 3 and 6, or if we took x's from factors 2, 3 or 7, or any set of 3 factors. Okay, so here we've got an x cubed, and it's corresponding to taking the x from factors 2, 3 and 7, so that kind of corresponds to the set 2, 3, 7 that's written here. Okay, and then the other 4 factors we take a 1. Okay, so for each of these sets of size 3, like 2, 3, 7 here, we get an x cubed. And so the total number of factors of x cubed that we get 1 for each set of size 3 in the set taken from the set 1 up to 7. And the number of possible sets of size 3 in 1 up to 7 is 7 choose 3. That's kind of the basic point about the binomial coefficient. It counts the number of subsets of particular size. Okay, so we've got 7 choose 3, which is 35 possibilities for choosing a set of 3 factors from which we're going to take the x's. Each one of those gives us an x cubed. So overall, the total number of x cubed is we get a 35x cubed in the expansion of this thing. And similarly, if we want to look at terms x to the 5th, right? So we have to take an x from 5 different factors and a 1 from the other 2 factors. So to get an x to the 5th, we have to choose which set of size 5. In this case, we've got 1, 2, 3, 4, 7. That's because we're taking the x from factor 1, factor 2, factor 3, factor 4, and factor 7. Okay, so that gives us 5 x's and therefore a term of x cubed. And we get 1 x cubed for every possible choice of a set of size 7. Set of size 5, sorry, and the number of possible sets of size 5 is 7 choose 5, which works out as 21. So we get 21 x to the 5th terms, and so overall we get 21x to the 5th. And the kind of extreme case where we take an x from every factor, so we have to have a set of size 7. There's only one possible set of size 7 in 1 up to 7, that you have to take the whole thing. So we just get one copy of x to the 7. The other extreme, we take no factors of x, so we take a 1 from everything. Okay, so we have to have the set of factors from which we take an x is just the empty set. There's only one possibility for that. So so we get a 7 choose 0, which is just 1 times x to the 0, which is 1. So this gives us a constant term of 1 in the expansion. Okay, so we can click here and we see the overall thing. We can write it in just a slightly different way if we want. So for every set A in 1 up to 7, we get, if we just take the x's from the factors corresponding to A, then the term that we get is x raised to the power of the size of A. So we've got a sum for all subsets A of x to the raised to the power size of A, but then we can group those A's according to their size. For the ones of size k, there's 7 choose k of them. So we can rewrite this as the sum from k is 0 up to 7 of 7 choose kx to the k. And if you want the actual numbers, it comes out like this. 1 plus 7x, 21x squared, 35x cubed, 35x to the 4th, 21x to the 5th, 7x to the 6th, and as we said, x to the 7, because there's only one way to choose a set of size 7.